Oh boy, it's been a little while. Um, yeah, I've been like busy with stuff, but I have made some progress since the last video. I'm thinking going forward, I won't try to post just on Fridays and Saturdays. I'll probably just like kind of just do it when I can, because sometimes Fridays and Saturdays are too busy for a YouTube video. But uh, so what's been going on so far? Well, if I want to, it okay. So it was seeming like if I want to launch this rocket, I will need to get some certifications. I still don't know all the specifications of how things will turn out on the rocket, such as how much thrust, how much impulse it'll have, and for reasons that I will get to momentarily, I may need to totally like redo all the math that I've done in previous videos. But anyways, so that's one thing I've been working on is getting certified. Um, I made my first attempt at an L1 certification like a week and a half or so ago, and I did not succeed. But okay, well, here's how it went. It like flew really nice for the first like few seconds, and then the ejection charge went off like way too early for some unknown reason. Uh, and so because of that, the the nose cone came off like way too early when the rocket was still moving fast, and so it like the nose cone detached from the shock cord, um, and uh, and so I lost the nose cone. And then furthermore, I forgot to take the rubber band off of the parachute that I put on there to keep it from dangling and stuff before launch, and so it just kind of fell out of the sky and hit the ground at like terminal velocity. But uh, seem to have mostly survived. I 3D printed a new nose cone for the next flight. Hopefully, this is a more secure attachment than with the last one. I think the reason the nose cone came off is because um, sometimes I have learned there can be some residual mold release on the nose cone if you buy them like commercially made. And there's like a plastic injection mold or something. And so I had attached it with like an eye bolt and epoxy, but it just like came right off. Like the epoxy didn't even stick to it. Um, but I just 3D printed this one, so hopefully this is a better, like more mechanical connection. um, yeah, but like it's not even scratched. Like it's totally fine. So I'll try again with this one. Um, okay, it might be like a little scratched. Like I think it hit on this side, and they're like there's just like a tiny little scratch right there. And what? Okay, so the biggest thing I'm concerned about is right here at the top. It looks like I don't know if you can see that, but it looks like this is the side where it hit the ground. It looks like when it hit, maybe you can see it from that side as well on the inside. Uh, Sort of along here, it looks like it sort of hit right there and like kind of folded a little bit on impact. It's still structurally sound for the most part, but I think I'll cut off a couple inches there, just to sort of have a cleaner, I don't know, just to get rid of that in case it causes any issues, but I think it'll be fine. So yeah, it's called Seraph 1. Seraph is the Hebrew word used for the fiery flying serpents in the book of Exodus. So, anyways, I also think, so when I attached my rail buttons, somehow this one like chipped off right here. I don't know how that happened, but I think it was after the launch. It wasn't from like landing hard, but it'll still work fine. But it's attached with a screw right here, same with the one down there. But this one, I think can kind of snag on the parachute sometimes. So the nail that it or the screw. So I'm gonna see if I can like clip off some of that excess length on the screw from the inside. If not, then I'll try to figure something else out, I guess. But oh yeah, and since I'm taking a few inches off of here, that'll adjust my stability, and so I want to add more mass to the nose cone. This nose cone is already much more massive than the last one, but I think I'll still want to add more mass um, to make it a bit more stable. But yeah, so that'll launch again on April 18th. That's the next launch day. And I think what I'm going to try to do is I'm going to try to do my L1 and my L2 certification launches on the same day, the same event. And for the L2 certification launch, there's also a test I have to take for that. I can take it online though, but I can try as many times as I want, I think. But if I don't pass the test, then I have to wait 7 days at least for the next attempt at the test. So I'll want to get it right on my first try, so that I can launch my L2 rocket on the same day. So I'll probably just like go and memorize all the test questions because I think they're just online. Most of the parts have arrived for my L2 rocket. We're still missing. I'm still waiting on the laser cuts for my fins and my centering rings for that other one. And I'm not sure if maybe I want to add another centering ring or something, but that's probably fine. Anyways, this guy ran on an H135 motor, and I'll probably use the same motor for my next one. And my L2 certification will run on a J425 motor. But anyways, so that's where I'm at with my certifications. So hopefully I'll get both of those on April 18th, if all goes well. What else has been going on? So I've been thinking about how it's gonna gimbal. I saw these little ball joint fittings at Home Depot, and I was like, maybe I could use that for my gimbal. But of course, if you wanted to gimbal in like in around 360 degrees rather than just like back and forth, then it's got to be a bit more complicated than just like one of these on each line, because I got to have a line for both oxidizer and fuel, obviously. So let's see, I was kind of brainstorming. I was thinking I could get 4 of these little ball joint guys and have like 2 on the bottom on one axis, so it could like gimbal like that, and then 2 on the top on a perpendicular axis like that, so it could gimbal like that, right? So like at the top hinge it can like gimbal like that, and then on the bottom hinge it can gimbal like that, and so it's like, so I can get all, like I can point it in any direction like that. And so I started brainstorming. I CAD'd and 3D printed these little guys to hold it in place. Let's see if it like does that to hold it at an angle. But anyways, so you would but I mean, okay, so once it's like put together, it ends up being kind of long, because well, first of all, coming from the injection plate, I need to have one of these fittings that will connect to the injection plate, because if I'm building my own engine, I as shown in previous videos, I've already like CAD'd and made one of these fittings that will successfully fit in right there. But the female end would be a lot harder to make on my own. So I'll have 2 ends like that coming from the the engine. And so above that, we'll have to have then the two lines um, that will each then need to like extend and like okay. So just like with the way it works out, it just like ends up being really long. Is basically what I'm trying to say. Um, and with them all being made out of metal, it's also kind of heavy. And I was originally envisioning this to be like maybe about a meter tall. Maybe I want to go higher than that though, taller than that. But anyways, so yeah, I would have to have one of these like adapters in the middle of the gimbal between the two joints, which adds a lot of length. Um, so I was thinking about what to do about that. Um, but I was at Home Depot again, and I saw that there are some shorter, just like bendy tubes. Um, it was, but like it's like 2 feet long though. So, I mean, at first I kind of shied away from that because like, whoa, that's kind of long. I don't know if I want something like, I mean, it might be kind of redundant to have it that long, but it's also like, I don't know, probably it might not matter that much. So I think I'll just forget all of this and just like put in the flexible tubes. Um, and so, uh, yeah, so that kind of got rid of that, simplifies things a lot. Um, and will hopefully save on weight as well. I uh, I also need to CAD one of these and like build something I can hook onto there so I can attach like a servo motor to it or something to turn the valve remotely and like the valve on board and stuff. So that's another thing that I need to get done eventually. In terms of the homemade uh, uh, pressure vessels, the um, well, okay, so I after testing it, I threw it against the ground to see how much force it would take to break it, and then it like exploded. But it actually reached like 150 psi, which is about what I need to run it at. And of course, it'd be good to test it at much higher pressures, but that was about as high as my air compressor went. So yeah, but I mean, it might work. And again, this is just like the 3D printed on the SLA printer, just like this thin little tank with the epoxy sculpt on the outside to strengthen it. And so I guess that epoxy sculpt is pretty strong. Strong enough, at least, seems like. But, I mean, I probably want to do more testing if I can, but that's okay. Whatever. What else? I think that's most of what there is to say. Um, oh, yeah. So I was, okay. So, I mean, now that I think about it might not be a problem, but I was reading through the Triple E launch regulations and stuff, and for liquid rockets, liquid fueled rocket engines, the only oxidizer they allow is nitrous oxide. So that means I can't use my hydrogen peroxide solution thing, which it might be for the best. There were a lot of like I mean, so much of the exhaust of even just the like propellants in the tanks would just be water, just be like dead weight. So maybe it's best just to get rid of that. It would probably also like slow down combustion, lead to a much lower like chamber temperature. Um, so maybe I should just ditch the hydrogen peroxide anyway. But if I'm using nitrous oxide, that's much harder to get into a liquid form, requires much higher pressures. Might even want to like uh, lower the temperature a little bit. Um, and it also said that I think the tanks need to, or at least the oxidizer tank needs to be pressurized by the vapor pressure of the oxidizer. Uh, and so that means that would eliminate my pressure regulated feed system, um, which is unfortunate. I kind of wanted to have a constant pressure in the tanks to make it easier to throttle, but they also said that throttling is not allowed on liquid fueled rockets. Uh, but I guess I don't have to launch through Tripoli, uh, but I don't know what like launching independently would entail. Uh, I think Perplexity AI said I would have to like notify FAA or something like that. Uh, I have an aunt and uncle that own like 40 acres out in the middle of nowhere, so I think I could launch there. I think it has to be private property. Well, maybe not. Maybe I just have to get special permission if it's like on land owned by like the Bureau of Land Management. But man, there's a lot of regulations around this stuff. So but if I'm changing that up, then I'll have to redo all my math regarding the tank pressure and temperature and stuff, or chamber pressure and temperature, um, and do all that. Um, but that's okay. But I'll also have to find a better solution for my tanks. Um, Maybe those seamless aluminum air tanks would work well that I think I mentioned in the previous episode. But anyways, and then with the injector, that's what most of my thought has been going towards lately. Um, the injector plate. Okay, so one big lesson that I'm learning with this project is that um, engineering is not just about designing something that works, it's about designing something that both works and that you can build and then like fabricate. Fabrication is not trivial. so um, so I've been thinking about how I'd manufacture my um, injection blade and the rest of the chamber and nozzle and stuff. Originally, I was thinking um, I could just like order it 3D printed in metal, but I started thinking, maybe that's like too expensive. I'm probably gonna want to iterate on it and like do multiple copies, and so like that'll add up over time. Um, and so the alternative might be to have it like machined. Um, I have access to a CNC lathe and CNC mill through my university that I'll start at in the fall. Um, so that's something I'll probably have to do with that. Um, Once I figure out the new uh, temperatures and pressures and flow rates, I'll have to, for the injectors, you have to make the like cross sectional area of all the little holes have like a specific sum. So I'll have to figure out what that will be for my ideal flow rate and stuff. And but I'm okay. So the two main options I'm I'm weighing for my injector design are the pintle injector and the just like a plate with holes basically that where they like the holes are like at an angle so that the two propellants like come and meet each other and then like spray out like that. Um, and so the latter is probably much easier to manufacture. It would just be like a plate with holes in it. But I kind of like sort of the style of the pintle injector. The pintle injector. I'm not really sure what the trade-offs would be, so I'm thinking I'll 3D print both of them, just in like PLA or with my resin printer, um, to maybe get an idea of how they would compare in terms of how well they spray out the evenly spray out the propellants. Um, so I mean, I guess that's what I'll do next. I'll start catting the injectors, these both a pintle injector and a, I don't even know what it's called. It's just like a, where you just have like the two streams that like leave the plate like at an angle, and then like they meet later and hit each other in such a way that they it atomizes the propellants. So yeah, I'll try both. Um, the pintle injector would definitely be harder to model and produce, but maybe it'll have certain benefits. If okay, so if I'm not launching through Tripoli, and I find a way where it's legal to like have active throttling in flight, then the pintle injector does make that a lot easier. Um, and so that's one big advantage it would have. Um, so yeah, we'll see. I'll just like yeah, I'll 3D print some things and run. So if I'm using nitrous oxide, I can probably keep my what's it called, isopropyl alcohol. I could probably keep the isopropyl alcohol as my fuel, even if I'm using the nitrous oxide. But that means that I'll have um, a both gas and liquid being injected into the combustion chamber, and so both of these options for the injector design would work for that. But where was I going with this? I can't remember. But anyways, um, well, I just drew a blank. Well, okay. Oh yeah. So but before I can um, model those, I have to again redo all that math and stuff and figure out exactly how much total area I want to be flowing each of my propellants through, so that I can get all the measurements right and stuff with my injectors. So those are kind of the next steps, as well as figuring out all the like laws and regulations around this to see what it would take to launch this legally. Um, so yeah, I think that's all for now. So goodbye.